Hey, welcome back everybody. This is Cool Coder, and today I'm looking at LeetCode 121, best time to buy and sell stock. So in this problem, we're given an input array of prices where the value is the price and the index is a given day. So what we want to do is we want to find the maximum profit by buying the stock on a certain day and then selling on a different day in the future. And we want to return the maximum profit. So if we look down at the example, we're given this input array, and we'll see that on day 2, we can buy the stock for 1, and then on day 5, we can sell the stock for 6, which will give us a profit of 5. And that's the idea of what we want to do. And we cannot travel back in time. So basically what that means is if we were able, we could buy on day 2 for price of 1, travel back in time to day 1 and sell for 7, which would give us a return of 6. But we cannot do that. We cannot travel back in time in real life or on this problem. So that is not allowed. We can only sell on a future day. So that's pretty much it. So basically, to solve this problem, what we're going to do is we're going to loop through the input array, and we're going to keep track of the best buy and the best sell. That might make more sense when we walk through it. This is kind of a neat way that I've found to solve this problem, and it's not super complicated, but let's just get started. So what we're going to do is we're going to, like I said, loop through the input array, and we can go ahead and set best buy to the first value. So best buy will equal 7 at the moment, and then best sell we can equal to 0. So now that we are in our loop, we're going to again keep track of best buy. So we want to find the minimum, right? So we want to buy it when it's the cheapest. So we want to buy it on the lowest day. So to do this, we're going to find the minimum of best buy and in. So we are currently, this is the number we're on. We have already set best buy to 7, so it will be the minimum of 7 and 7. So basically, this isn't going to change. This will stay to 7. And then for best sell, we're going to get the greatest value, and we're going to say take the max value of best sell, which is 0, and then best buy minus the current number, which is 7, right? So the max value of 0 and 7 minus 7, which is 0. So it's going to be 0 currently. So now we're going to move on to the next. So now we're on 1. So we can update our best buy. So we're going to take the minimum of best buy, which is 7, and in, which is 1. So obviously 1 is less than 7, so this will be updated to 1. And then we're going to update best sell by taking the max of best sell, which is currently 0, and then best buy minus in, right? So this will be 1 minus n, which is 1, so still 0. This will not change. So then now we go on to the next item, which is 5. So we're going to take the minimum of best buy, which is 1, and n, which is 5. So the best buy is going to stay 1, and then we're going to update our best sell, which will be the max of best sell, which is 0, and best buy minus n, which is 5. what you'll see is we'll actually have to subtract the other way. We'll go n minus best by. So 5 minus 1, so we don't go negative. And so this is going to be 4. So we're going to now, this will now be updated to 4. And so you get the idea. We're going to move on. This best by will not change because 1 is the smallest value. And then we'll move on to 3. And then we'll move on to 6. So best by is 1. N is going to be 6. So then we're going to, best by will not update because we want the minimum, which current minimum is 1. We're going to move on to updating the best cell. So we're going to take the max of best cell, which is actually 4 currently, and n 6 minus best by, which is 1. And then this is going to be 4 and 5. So obviously 5 is greater, so this will update to 5. And that's how we get this value here. And then after we loop through everything, we can return the best cell. If there's a case where there is no best cell, then we have, like I said in the beginning, we set our best cell to 0. So at the end, we can just return our best cell. And so the time complexity for this is going to be O of n because we're just looping through the input array once. And that's pretty much it. We're not storing extra memory or doing any nested loops or anything like that. So, so that's pretty much it. Let's go ahead and code this up. So like I said, we're going to have our best by, which we can start at the first value. And then we can have our best cell, which will start at 0. And then we can loop through our input array and update best by. So best by is going to be the minimum of best by and n. Then we can update best cell, which is going to be the maximum of best cell and n minus best by. And then that's it. After we loop through all of the input array, we're going to return best cell, and that's it. It's pretty simple. Let's go ahead and run it and make sure it works. And that's it. So thanks for watching. I hope you enjoyed it. I hope you learned something, and I hope to see you on the next one.